This video will continue our discussion of double integration with another problem finding volume. So we have this region. I went ahead and drew the region because it was going to take me a bit of time and I didn't want to have you watch me draw. But I'll talk about what I did to help me draw this. I see that x is caught between 0 and pi over 3. When I first started beginning to sketch, I just put my pi over 3 and tried to make it look like it's climbing uphill but not to the peak yet. And then I thought about it, and the best way I could probably do this is just go ahead and graph my sine wave all the way up to the peak, pi over 2, and then just know that pi over 3 is right next to it. And then I put my values in there. That's a radical 3 over 2. It's pretty small, but I had to because that gap's not very big. Alright, so that covers the region. Remember, we're finding the volume of the surface that's above and below that, wherever it may be. I have cosine of x minus y. That looks a little janky there, but yours will look fine. So let's go ahead and start this process. So I take my double integral. I don't know what I'm going to do x or y yet. I'm going to write it down, cosine of x, and then minus y is separate. And then I got to figure out what I want to do first. Well, if I'm looking at how my region is defined, I can see a clear with y. I can see y starts at 0 and goes up to that function. If I did x, I would have to start from here and go up to pi over 3. But my function's already solved for y, so it really wouldn't make sense to do it this way because I'd have to solve for x then, which means we would be dealing with an arc sine. So I'm going to deal with y first. It makes the most sense to me. So y equals 0 up to sine x, and this makes sense too because I'm going to plug that in, and then now x's can just go from 0 to pi over 3. Meaning the last thing that's going to come out of my integral will be a constant, which is what we need. Alright, so we're going to take the integral first with respect to y. And this is going to feel a little strange, but it makes sense with partials. Okay, so I take my integral of cosine of x with respect to y, and I'm going to just going to introduce a y to it. Y times cosine of x minus 1/2 y squared, and then I got dy dx. Oh, we got to plug our bounds in. So let's plug our bounds in, don't forget that. So y equals 0, that's going to be all right. And then y equals sine x. So hopefully that helps us in the long run here. I don't have dy anymore. I wrote an identity down up here, and I thought maybe I was just kind of trying to use my foresight that it may be used. It may or not, but I know that I mentioned this identity in a past video, so maybe you write that one down too. It's very similar to the other one. We'll get you out of sticky situations. Right, let's continue with our integral. We have the integral from x equals 0 to x equals pi over 3. We haven't done anything with that. Now we're going to plug each thing in. Okay, the zeros are going to just zero out, thankfully. So we get sine x, cosine x. That's going to help out. And then minus 1/2 sine squared x. There we go. I was kind of seeing it. There is a sine squared in this. To do this part, because it gets so weird with all the different parts going on, I like to break this down into two integrals and deal with them differently, separately, meaning. So I'm just going to write these down real quick. And then I got minus. I'm going to go ahead and pull that half out of here. I keep the same bounds. We can split them across minus signs. It's perfectly fine. I'm going to have to do two different types of substitutions. That's why I did in two. So let's do u for the first one. So the first one to make sense would be to let u equal sine, because du is going to be cosine dx. All right, so we can start that process. Let's go ahead and plug the u's in. Sine of 0 is 0. And then sine of pi over 3 is radical 3 over 2. And then I just have a u du. Minus, okay, I keep my half. And I'm just going to rewrite this integral for the moment. This is going to take that identity that we wrote down at the top. It's going to be a 1/2 times a 1 minus cosine 2x dx. Really helps us out. All right, I can do that first integral. We can go ahead and do that. That's going to be 1/2 u squared. And then we're going to plug in 0, and we're going to plug in radical 3 over 2. Minus, okay, that 1/2 is going to come out to make a 1/4. All right, and then I'm going to rewrite this integral. Actually, let's go ahead and do our small little u sub here. I'm going to do this in pink, but we're going to call it w because we've already used u. I'm going to let this be 2x, which means dw is going to be, it gets really tricky with that 1. Let's just eyeball it. I'm like starting to think about that 1 there. That's kind of tricky. Let's really rewrite it, and then I'm going to help you eyeball it because it's a little easier instead of doing a u sub for something that small. So, okay, I got pi over 3. I already pulled out the half, so I got a 1 minus cosine 2x. The reason I didn't want to do a u sub is because I don't need it for that 1. You could separate your integrals again if you'd like and get there. Okay, we can go ahead and plug this stuff in now. I got 1/2 times radical 3 over 2 squared. A minus, and then it would be a 0. Okay, so that's nice. Okay, minus 1/4. Let's go ahead and do our integral here. I get an x, and then this is the way I like to write this down. Okay, I know it's going to be a minus sine 2x. Because minus sine 2x is going to give me minus cosine 2x. But with the chain rule, I would have to multiply by 2. So I need to put a 1/2 right there, because when I multiply by 2, it's going to cancel that 1/2 to get me up to this 1. If you need to do a u sub, please do. Just separate this integral into 2 parts, so you don't end up messing a u sub up for that 1. It shouldn't matter, but just to be careful. This is ran from x is 0 to x is pi over 3. All right, we got 1/2 times, we can go ahead, I guess, simplify this, 3 over 4, minus, and I'll just do one step at a time because I know I'm going to rewrite stuff here as well. Plugging in 0 is going to zero everything out, so I get a pi over 3 minus 1/2 times, okay, and then I times, it's 2 pi over 3, which is going to give me the same thing as pi over 3 because it's y, and the positive y, so that is, what, radical 3 over 2. Great. The 0 is going to zero out both of them. I don't need to do that part. So we get 3 over 8 minus pi over 12 plus, and then we can multiply all this out. I'm going to get a minus 1/4 out front. That's going to be over 16, so it's radical 3 over 16. Let's double check that. That's going to be 8, 16. Yep. So I think that's a great answer. It doesn't simplify in any way there. I mean, you could probably get it down to one denominator, but honestly, it's not really making our answer any simpler for us. Right, so get your integration practice in.